All right, so we have studied graphing absolute values already, right? What shape was it? A V. So the name of today, as Nathaniel read it for us, we are studying quadratic functions. Okay. The parent function, we will always have a parent function. Doesn't matter what we are learning. So the parent function for this is y equals x squared. What was the parent function for the absolute value? Y equals absolute value of x. Okay. Now let's look at the HK form. Can you guys see that it's super similar to the HK form of the absolute value? Yeah, it's still f of x equals. You still see an A value in there? Yep. You see an H value in there? You see K value in there? Yep. Except it's squared versus an absolute value. Okay. Transformations, they will be exactly the same from when you study absolute value all the way until you take the second semester final. It will never ever change. A value will always do the same thing. H value will always transform the same way, and K value will always either go up or down. So question 1 says, graph the parent function, which is y equals x squared. Then find all of the characteristics. I'm giving you guys 5 inputs already here, so let's plug it in. Okay. When x is -2, we plug in -2 and then close it square. So Brandon, what's -2 square?
4.
Perfect. When x is -1, open quantity square. Malin, what's -1 square?
1.
Perfect. When x is 0, 0 square is what, Jake?
0.
Perfect. When x is 1, 1 square is what, Naomi?
1.
When x is 2, 2 square is what, Mariana?
4.
Perfect. Let's plot our dots. Okay. Before we even plot, what shape should this be? A what?
A U.
A U. Guys, a V is only reserved for what function? Absolute value. Okay, so -2, go up 4. -1, go up 1. 0 is 0. 1 is 1. And 2 is 4. Okay, let's look at the shape. Guys, it looks like it could be a V, but please do not make it a V. Okay, I need you to round out the bottom here. Okay, round out the bottom. Round out the bottom. If you miss your dots, you can always make your dot fatter. But the bottom should be a roundabout. All right, H and K value. Since it is the parent, Slater, what are the H and K value for all parents? That's right. It's told to be 0, 0. Okay. Axis of symmetry. By the way, let's recall what that was again. What was the axis of symmetry? Is this line, right? So when you fold it, what's happening to the left and right? They reflect each other. They should be exactly the same. They should be symmetry. So what's the line for this particular axis of symmetry? X equals. Remember, axis symmetry is a line, so you have to give me x equals to 0. Okay, it's not a dot, it's not a point. From the graph, does it look like it has any x-intercepts?
No.
Does it cross over the x-axis ever? Sure. How many times? Once. At what location? 0, 0. Parent functions are normally pretty boring, okay? How about y-intercept? Does it cross the y-axis? 0, 0, okay? What do we say the domain is what? All real numbers, okay? You can also say from -infinity to positive infinity. The range is, y is bigger than or equal to 0. Or, how do we write it in interval notation? From 0 all the way to infinity, okay? Now, let's look at this. Do we have a decreasing interval and an increasing interval, or just one of those or none? Both, okay, just like your V. When we write increasing and decreasing, we must always start from the left of the x-axis and keep going to what direction? to the right. Where is the breaking point? Where's the point of separation between those two intervals? At your vertex, right? Okay, or the min-max. So if I'm starting over here, what do we call this point over here on the x-axis? Negative infinity. I'm going to keep going. Is it what's happening to the y value if I keep going? Is it going down or up? Okay, remember I'm starting here. So here's me walking on the x-axis. If I can draw it. There you go. I'm going this way. Is the y value starting really high or really low? Really high. Every step that I'm taking to the right, what's happening to y? It's getting smaller and smaller. So that half over here, is that decreasing or increasing? Decreasing. Decreasing from negative infinity. And where does it start changing? At 0. Okay. Then I'm going to keep on going. Okay. This point right here is where you're taking a little break. So I'm going to keep going on the x-axis. If I keep going on the x-axis, what's happening to me? Am I getting higher and higher or lower and lower? Yeah, right? I'm climbing this up. So if you are climbing, is that increase or decrease? Oh, I just wrote in the wrong spot. Sorry. I just wrote in the wrong spot. That's why. So decreasing is from negative infinity to 0. We were talking about. And then increasing. So because I keep going from left to right. You never ever go up or down. You keep going from left to right. When you keep going from left to right, the y value on the right side went up. So that's increasing from 0 to infinity. Now let's talk about rate of change. That's fancy for what? Slope. Okay. Normally, when we are graphing lines, would you guys agree that you have the same rate of change? Okay. So every step you take is the same y value of increase or decrease, and so on and so on. How about, and then we talk about the absolute value. It has two slopes. That one was positive, one was negative. Then this one, do we have a rate of change? Is it, remember, rate of change is constant. It has to be the same for every x value that you're taking. So I'm going to move it in really big. Let's take the very first step. I'm going to start at 0. If I start at 0, okay, and take one step to the right, what is that change in y? 1 unit. Then I'm going to take another step to the right. What's this change value in y? What was that value? 3. Is that constant? No. Is that the same? No. So because the slope is not the same from one x value to the next, we call it, right now in this class, we call it varies. Okay. In the future, if you decide to take higher math classes, you will learn to find out what they are. But right now, we're going to say it varies from one to the next. Is this a one-to-one function? Nope. Does it have a minimum or maximum value? Minimum value. That means max is none right away. Minimum value of what? 0 at where? At x equals to 0. Can you guys see that all of these characteristics are very similar to the absolute value? Okay. The only difference is really your slope, your rate of change. Transformations refresher. Let's review really quickly. If your a value is a negative value, what do we state that? Reflect over the x-axis. Okay. So once we've taken care of the negative, we now move on to, hey, is it bigger than 1 or is it less than 1? So if a is, let's say, a half or 3/4 or 9/10, because it's less than 1 right there, what kind of transformation is that? Compression. Vertical compression, you're right. Vertical compression, factor of that value. Factor over a. So if a is a half, then we are going to vertically shrink it by a half. Vertically means what axis? X or Y? y. Okay, vertically means is y. Now, if a is 2, 4, 6, 8, 10, 11, 5, that's bigger than 1. What type of transformation is that? Vertical stretch by a. By a factor of a, whatever a may be. H, now this H value is super confusing to some of us, okay? I'm gonna wait for a second because I know not all of us have printed notes, okay? So I won't go too fast. It's being recorded, so technically, if you are ever need to go back and listen and review, it's all there for you. Okay, so H is super confusing for some of us. Let me move back to this HK form. Can you see in the equation, in the HK form, it's always stated as x minus h, right? And then it's always plus k. So if I make up an equation really quickly, so i.e., this is just totally made up, okay? F of x equals x plus 4 quantity square minus 3. Just making this up. What is your H value? Yes, it's -4. What is your K value? -3. So in the H value, because the equation itself is an x minus already, you have to have a -4 to make it a +4. The K value doesn't change, okay? Now, H is negative. That means you're going what direction? To the left, okay? So H, if it's negative, we go left. That means if H is positive, we go to the right. However,
I'm sorry.
That's okay.
I can't wrap my head around it. What is the justification behind always having it negative, even if you're given H as a positive?
Actually, this goes back to this, okay? Can you see that we have, yeah, I'll move back up. Good question though. Okay, so do you guys remember back in the days when we did point slope form? Okay, I'm going to give you a slope, let's just say 1/4, and a point, and this is all connected, okay? A point of whatever, 1/3, okay? Ready? Shh. The point slope formula says back in the day, y minus y1 equals m times x minus x1. Would you guys all agree with that formula? Okay, let's fill this in really quickly. You got it? All right, y minus what? 3 equals 1/4 times x minus 1. Shh, boys. Now, let's look at your, what if I don't want to call it x1 and y1? I want to call it h and k. Okay. I want you guys to look at it. If I decided to solve for y, would you guys all agree now I would move the k to the right side? Okay, just make the connection for me. So if I move the k, can we all agree it's now an addition of k? Whoa. If I move that 3, would you agree now this is an addition of 3? Right? A quarter, I'm going to write the quarter back. Times x minus 1 plus 3. Yes or no? Ah. Can you see now why the h value is always the opposite and k is not? Okay. It's all back to the point slope form. Good question. All right. Yeah. All right. Hey, so K, do we do the opposite for K ever? No. So we're going to write K equals positive. That means we go up. If K equals some negative number, we go downward. Okay? Yes. If let's just say the made up one here, like if it's this one right here, Dahlia, if it's a -3, K is -3, so we're gonna go down 3 units. Okay. For this one, h is going to be a -4, so we go left 4 units. Okay. Okay, let's practice. Actually, let's read this table really quickly. Can you help me read the guidelines? How to graph in vertex form. Diego, help me read number 1. Okay, let me tell you right now, I'm going to be asking for 5 points, okay? The reason is if you make 3 points, you tend to make a V, and that's incorrect, so I'm going to be asking for 5 points, okay? Alyssa, can you help read number 2, please? Yep, save the transformation from left to right. Not because it's any better. The reason I normally want it A, H, and K is so that way you don't forget any of those, okay? If you go H and then A and then K, sometimes you go out of order and then you forget. Sophia C, can you help me read 3, please? Good. Chizuki, help me read 4, please. Good. 5, Kenzie? And then Autumn, last one, hon?
Analyze your graph, such as does it open the right way? Did the graph go right as stated?
Okay, so you know what happens? Sometimes you on your transform spelling or verbally stated, you say, go right by 5. And then on your graph, you actually went left. So you always want to analyze, okay? Did you state it, the verbiage of your transformation, does it match up with your graph? Okay, so always just quickly glance at that. All right, example 2. We have 2 examples that we will work on it together, and the last one I'm going to have you guys do as a check when understanding. Okay, number 2, f of x equals quantity x minus 3 squared minus a 1. If there is no number at all in front of the quantity, what number is that? 1. So a value is immediately 1. H value, what is it? 3. K value, -1. Okay. I'm going to hold it right there before I go any further. Okay. Shh. I'm going to hold it right there before I go further. Okay, transformations. Because your A value is not bigger than 1 and is not smaller than 1 and is not negative. Do we have any stretches or compression? No. Okay, so we have 2 transformations total. The first one, H is positive. What direction is that? To the right. To the right, to the right. How many steps? 3, right? 3 units. Okay. Now you got K be negative. Down. Okay. Down 1 unit. I don't know if it's a down sound. Oh, actually, isn't it like a... All right, parent function. You have y equals, what's the parent equation always? Y equals x squared. You are provided with 5 inputs. Go ahead, quickly give me the 5 outputs. Consult with your team when you're ready. So Christian and team, whenever you are ready, Christian, give me the 5 outputs for the parent. 4, 1, 0, 1, and 4. Perfect. Now, I gave you another T on the right side of the parent because you're about to transform it. Do we do anything with an A value of 1? No. Do we do anything with an H value of 3? What do we do with that? You said it's going to what direction? What are we changing? All X values, all Y values? X. We add or subtract? We add. H is positive. We add 2X. Okay. Remember, going right means the X value will have to get bigger. And for it to get bigger, you have to add. Okay. How about the K value being -1? You change what? All Y value, we add or subtract? We subtract. Okay. So what I would like for you to do, take all of your inputs and transform it. Okay, all 5 inputs, transform it. Once you're done transforming all of your inputs, take all of your outputs and transform that as well. So do both. All right, Elena, whenever you and your team are ready, give me the 5 inputs transformed.
1, 2, 3, 4, 5.
4, 5. Good. 5 outputs, Riley and team. Whenever you and your team are ready, give me all 5 outputs. -1. I'm sorry, one more time.
0 and 3.
Oh, what happened? 0 and 3. Someone confirm? All right, let's plot. Since you guys agree, we will plot those dots. 1, we are now moving up 3. And then 2, staying 0. 3, negative. 4, 0. 5, and 3. What if you make a V out of this? You will be wrong. You're right. Your teacher will cry. Okay. Round out your bottom. Let's answer all of the characters in the box. Vertex. Can you, Brian, give me the vertex. 3, -1. Axis of symmetry, Alan and team. Axis of symmetry, hun. What did you and your team come up with? So close. Yes, sir. Much, much better. Now, if you look at the graph, Maggie and team, how many intercepts do we have, and what are they? How many X-intercept, I should say?
2.
2. What are those?
2, 0, and 4, 0.
Perfect. And 4, 0. If you look at the graph, this is tricky. Grace and team, do you think we are going to have any y-intercept?
No.
The graph says no, but from my graph at least, your graph maybe, my graph doesn't look like it's intersecting the y-axis, but because the arrows are going upward, you will. So when your graph doesn't show it, you have to find it what method? Algebraically, okay? Y-intercept means x equals to what? 0. Okay. Okay, let's plug it in. Y equals quantity 0 minus 3 close. Yeah, from the equation they gave you. It's my computer is it's misbehaving. You know, every time it does that, somebody says Minecraft. It does not fail. Let me tell you. Yeah. I just found out what Minecraft was last week, and I just found out what esports was this year. I'm like, what? There's esports? I'm very old and I do not know. Okay. I had to plug it in before it does that again. All right. I gotta. Yeah, it might be. All right. Let's plug it in again. Y equals quantity 0 minus 3 square minus 1. Okay. 0 minus 3 is what? -3. -3 square. Be very cautious. 9. Okay, so 9 take away 1 will give me a y-intercept at 8. We're going to write it as a point, so it's going to be 0, 8. Domain. What would you want to say for the domain, Hannah? Good job. All real numbers. Or we can even say it from -infinity to infinity. Okay. The range. Kyler, what would you like to say for the range?
X is greater than or equal to -1.
You're so close. It is bigger than, or you could say -1, but it's not x. Yep, it is y. Interval notation class, how do we write that? -1 bracket all the way to infinity. Do we have both increase and decreasing, Devin, intervals? Yes. Where does the increasing start and where does it end? Good job. Okay. Decreasing interval from where to where, Trevor?
Decreasing from the negative infinity to 3.
Good. Can you guys see the breaking point for the increase decrease is where the axis symmetry is? Okay. They're all connected, okay? The rate of change, Megan, what do we write for the rate of change? Wyatt, is this a 1-to-1?
No.
No. Sophia and Hun, do we have a min or max? Minimum value is what? At x equals to? Good. That means maximum is none. Okay, I'm going to hold that up so you guys can copy. If you have notes that's printed, you can get a head start on 3, at least state the A, H, and K. Yes. Why? Not yet, because she's -5, that's right. Right, here we go. Olivia, A, H, and K. What are those three values? Perfect. Nicely done. Okay. Yes. Ah, is it -10 for H, y'all? No, we don't distribute them. Do not distribute. Remember, why the formula, the equation of your equation of the equation. Let me. Sorry, my screen is. Can you see our HK form right here?
Oh,
Yeah, you don't distribute them. You leave them as a quantity, okay? Okay. The A value being negative, class, it means right away how many transformations? 2 for just the A. So 2 for the A value being negative, 1 for the H value being -5, and 1 for the K value being 8. So you have 4 transformations total. Okay. Dahlia, can you give me the 2 transformation for your -2 for the A? The first one would be? A is -2, so it should have 2 transformation total. Okay. So think of it like this. -2 is kind of like -1 times a +2. Okay, so the negative value is what kind of transformation? Team? Yeah, it's teamwork, guys.
Oh, is that like the
That's the 2. The negative is not a compression or stretch. What is it?
Oh, it's reflected on the x-axis.
Good. It's a reflection, right? Reflect over the x-axis. Okay. Now then the 2 does what? In team, talk to your team. The slope is not an exact number in your quadratic, right? It varies. So if A is bigger than 1, Dahlia.
Oh, is it
It is, because it's bigger than 1. Vertical stretch. Factor of how much, Dahlia? Good. Because it's bigger than 2. If we are to multiply your y values by 2,
Negative, isn't it less than 1?
no, but the negative is broken down into a negative 1 times a positive 2. A negative itself is a reflection, and then the 2, 1/8 is like less than 1, like a half or 3/4 or 5/6. Correct. A negative is always a reflection. Okay. Greater than 1 for it to be a stretch.
No, but like, since it can never really be negative.
Correct. The negative is always a reflection. It has nothing to do with stretch or compressions. Okay. Ready? Then you have an h value. Megan, h value -5. What's the transformation? Talk to your team and stay focused, please. Left, how many? Left 5 units. Good. Okay. Then we have a k value of 8. What type of transformation is that? That will? Yep, shift up 8 units. Perfect. Okay. Now the parent function, are the values ever going to change? Nope. Here we go. Parent y equals x squared. Okay, go ahead and quickly give me the 5 outputs, okay? Whenever you are ready, Chris, give me the 5 output for the parent. 4, 1, 0, 1, 4. Okay. Let's use our 8, h, and k to transform. You have an a value of -2. What are we changing? All the y values, all the x values? Y. All the y. Is it vertical, stretches, or compresses? Guys, vertical is which axis? Up or down? I mean, up or down. Y or x? Y, because this is going up and down. That's vertical. So take the y and multiply to -2. Okay? H is -5. Remember, we stated that it was going to go left. What axis is that? X. So we're going to take all the x and do what? Add or subtract? Subtract. Because we need to show that's getting smaller and smaller. Then we said k is 8, and we said it went up. Is that x-axis or y-axis? Y. So we're going to go and take all the y values and do what? Add 8. That's right. Okay, similarly to before, I want you to take all the x-axis from the parent and transform. Okay, take all the parent function value of the y's and transform. And then I'm going to call on you to give me all of those. I'm looking for all 5 x's at once. I'm looking for all 5 y values at once. Go. Santana, whenever you're ready, give me the 5 transform x's.
-7, -6, -5, -4, -3,
Thank you. And you have the y too?
Oh, I have the y.
Oh, yeah, give it to me.
0, 6, 8.
Oh, wait. The last one is -2 or -3?
-3.
Okay. Okay. Well, I'm sorry. What's the y?
0, 6, 8, 6, 0.
0, 6, 8, 6, 0. If you guys found those already, can someone confirm those before I plot? Yes. Thank you. All right, I'm going to plot. -7, staying at 0. -6, go up 6. 6. -5, go to 8. And then back to symmetry. Should I make a V? No. Make a U. Okay? All right, characteristics. I want you to take
a minute head start in your team to get fill in those boxes, and we'll go just to see how far you can go. I do not expect you to finish them all. What? The first minute?
You can struggle in there just to see what to say. I don't think you're very confident in what to say. Or what do you think?
Fill out the characteristic box, please. Once, looks like some of you are done. If you're done, can you confirm, verify your box solutions with your neighbors? Fill out the box. If you can't do it, talk to one another.
Yes. You're stuttering a lot. What you're trying to say, aren't you? Okay, whatever.
Okay, we'll start with Hun. What is the vertex, Hun, that you wrote down?
Vertex is -5, 8.
-5, 8. Okay. I'm going to hold this tight so all the side conversations can stop. Side conversations. I need you guys to stop. Thank you. Axis of symmetry. Emily, what did you write down? Emily's gonna give me the axis of symmetry, hon, on the box. What did you write? -5 equals x. -5 equals x. Is that the same thing as x equals -5? Yes, perfect. It's okay. I just want to make sure. Okay, I'm not talking over you and you're not talking over me. Okay. X-intercepts. Do we have any? If so, what are those? Nathaniel? X-intercepts. -7, comma 0. Is that all? Thank you, sir. Y-intercept. Brandon, do we have any? Yeah? We can't see it though, right? So we have to find it what? Manually. Would you agree? All right, class. Y-intercept when x equals to 0. We have to plug in 0 for your x value. So y equals -2, open quantity, 0 plus 5, quantity square plus 8. 0 plus 5 is what, Brandon? 5 square? Good. -2 times 25, Brandon. What is that? -50 plus 8. And final answer. Whoa. Can you guys see why? That's why we don't have it on the graph. Our graph is only a -10 by a +10, so therefore, you're not going to see a -42. Okay. Domain. What should we state, Malin, for our domain? All real numbers. Or from -infinity to what? +infinity. The range. Jake and team, can you guys tell me what the range should be?
Y is less than or equal to 8.
Y is less than or equal to 8. Perfect. Or how would we write that as interval? -infinity all the way to 8 in the bracket. Very good. Increasing interval. Slater, from where to where, hon? So -5. Okay. Decreasing interval. Diego, from where to where? You mean -5 to positive infinity? Decreasing is from -5. Remember, we're always going to go on the x, okay? I'm going to keep on going on the x. So I'm starting at -5 on x, and where do I end? Over here. Yep, positive infinity. Don't follow the arrows, because I know that some of you guys do that. Follow the arrow, but don't. Rate of change. What do we? Alyssa, write for rate of change. What do you answer? What's your answer for 1-to-1? Sophia C. No. Do we have a min or max, Autumn?
Maximum.
Max, and what is your max, hon?
8 at x equals -5.
Good. I mean, this is none. Okay, the last one is not a lecture. The last one is you are on your own, in your team, that is. What's that 5 minutes of clock? You guys talk to each other. You have a second green tea already, Wyatt?
Well, like, is it 1-to-1? Like, no.
This is a tricky situation. There's no H. H is 0. Let's go around. Let's check what's standing. Hey, before you guys get so excited and start plotting in, notice how this is slightly different from our HK form, and some of you already stated earlier for me. If you were to rewrite this, okay, remember the HK form is something x minus h plus k. In this case, your plus k is a -2. What goes in there? I have an x already, but what's in there? X minus, yeah, there's nothing here. Can you see that this whole quantity is, so this is really x minus 0, x plus 0, it doesn't matter. Okay, so when you don't see a quantity, it's really, your h value is what? 0. When you do not see a quantity, your h value is 0. Now you can start. 5 minutes, and then we'll call on. I'm not project this on the whiteboard. I'm gonna call multiple teams to come out, fill different parts.
So when we have fractions on these tables,
If it rounds perfectly, yes. But if it's like 2 over 3, that's a 0.6, so I'll get us 2/3.
but like in the table one, it's easier for me to graph it. Is that okay? As long as I don't write my answers.
Yes.
So like as long as
Totally, for sure. Yes.
No problem. And then Mariana's in her own zone right now. Oh, there you go. What the frick? This is the response to number 14. It's not fun at all. Wait, I did not get a. Not like
What's your AHK value?
Yes.
Remember, A is negative something. I mean, immediately, how much transformation for just A? Negative itself, 1.3. So there's no A here. What one you check for you first? What are the two transformations? What else is like how is it y?
Not that.
Nancy, let's go. Gabby, let's go. Good, so that's just A value.
Observe. You see this? You see this? 2 times just Mariana. See this? You multiply it to negative, right? Add it. We start that again. It's not 5. And there you go, negative 5. No, never mind. I messed up again. That was 5.
What?
Wait, so it's negative 3/4y?
Okay, guys. Quickly check your AH and K values and check the transformations. Do you have the same exact thing? Yes, you should.
Next, what is the parent equation that we use for quadratic functions? Y equals x squared, not just x squared. You're just too excited for that. All right. So parent equation for, okay, y equals x squared. Shh. All right, guys, I need you guys to come back together because I need you to help me fill this in quickly. Ready? Kenzie, give me all 5 outputs for the parent.
4, 1, 0, 1, 4.
Good. So we are going to transform. We'll take the a and multiply it to the y's, and then at the same time we subtract 2 from the y's. X does not change for this particular case. So -2, -1, 0, 1, and 2. Give me all 5 outputs, please. Somebody. Oh, this is y. All other 5 outputs. -5. What? -2. What else?
No, -2 and 3/4.
Oh, -2 and 3/4. Okay. -2. -2 and 3/4. Good. I need you guys to stop right now. Let's plot. -2, go up 5. Okay, I need you guys to not. -2, oh, -5, thank you, good eye. -2, 4, 5. And then -1 in between 2 and 3, 0, comma, -2. And then once you have one side, the other side is just a symmetry. Okay. All right. Vertex is always h comma k, so that will never change. Axis of symmetry, it's always just x equals to h, which is x equals to 0. Thank you. X-intercept, because it doesn't ever touch the x-axis, we have none here, or is not applicable. Y-intercept, you already see the table, it's 0, comma, -2. The domains is always all real, or from -infinity to infinity. The range is from -infinity, and it stops at what value? -2. Increasing, it's from -infinity, and it stops at 0. That means decreasing is from 0 to infinity. The rate of change for all parabolas, they vary. 1-to-1 is definitely not a 1-to-1, so it's non-applicable. We do not have a minimum value. We do have a maximum value of what? -2. At what location? X equals to 0. And that's an egg roll, y'all.